Hello everyone. In this video we are going to discuss one of the very important topics, that is carbon and its compound, which is there for grade 10. Okay, CBSE 10th, ICSE 10th as well as SSLC. So please watch the video till the end. You will understand each and every concepts which is there in chapter. Okay. So when we talk about carbon and its compound, so we are studying in a separate branch of chemistry, that is called as organic chemistry. Okay, what is organic chemistry? It is a branch of chemistry which deals with the study of carbon and its compound. Yes or no? So that is organic chemistry. So let's first discuss the sources of organic compounds. Okay, where are the sources of organic compounds? Okay. So organic compounds and its sources, you can see here. An organic compound is any member of large class of gaseous, liquid or solid chemical compounds whose molecules contain carbon. Okay, so it has various sources like plants, animals, coals, petroleum, fermentation, wood. Plants how? See, where compounds like sugar, starch and cellulose. Yes or no? So sugar is a organic compound, starch same as cellulose. Yes or no? Animal sources like urea, proteins, fats. Okay, these all are organic compounds. Coal, when you do the destructive distillation of coal, it produces benzene, toluene, naphthalene, which are all organic compounds only. Petroleum, a large number of organic compounds like gasoline, fuel, gases, petrol, naphthalene, actually all are obtained from the petroleum. Yes or no? Fermentation, yes, compounds like ethyl alcohol, that is ethanol and acetic acid are obtained by fermentation. Wood is also a source of organic compound like methyl alcohol, acetone, etc. are obtained from the destructive distillation of wood. Similarly, synthetic methods are there, like most organic compounds are synthetic in nature. Yes or no? Next, we talk about a very important concept first. Let's discuss about hydrocarbon. Okay. Before studying hydrocarbon, one very important concept is there. They may ask you question like why carbon forms millions of compound, or discuss briefly the versatile nature of carbon. Okay, so carbon is forming millions of compound due to few unique properties. Okay, first one is a catenation. First one is what? A catenation. Okay. Okay, next tetravalency. Catenation and tetravalency. Let's talk about this topic. Unique nature of carbon. Okay, first one is what? Catenation. Catenation means what? Self-linking property of carbon atoms. Okay, due to which it forms long straight chain. Okay, it can form branched chain. Okay, and it can form cyclic chain. This property of carbon atom to form long straight chain, branch chain and cyclic chain, this is called as what? A catenation. Very important. And second property is what? A tetravalency. Okay, see, when we talk about carbon, atomic number of carbon is what? 6. Electronic configuration 2, 4. Yes or no? So what happens? Carbon is having 4 valence electron. You can see 1, 2, 3, 4. So what it will do? It will make 4 bonds by sharing its electron with other atoms. Okay, so this tendency of carbon atom to make 4 bonds with other atom is called as tetravalency. Yes or no? One more reason is there why it is forming large number of compound. It is due to the tendency to form multiple bonds. Carbon can form double bond as well as triple bond. Yes or no? And one more reason we can say versatile nature of carbon. It has the ability to form isomers. Okay, we will discuss in the later part of chapter. What are isomers? Isomers are the compound, okay, having same molecular formula but different structures. Okay, yes or no? Now the chapter starts here. Hydrocarbons. When we talk about hydrocarbons, the compound containing hydrogen. Okay, hydro for hydrogen, carbon. The compound containing hydrogen and carbons are mainly called as hydrocarbon. Yes or no? So when we talk about hydrocarbons, is of two types, saturated and unsaturated. Saturated means contains only single bond like alkanes. Unsaturated means contains double bond or triple bond like alkenes and alkynes. So we are going to discuss this first hydrocarbon, alkane. Okay, so you can see here the compounds which contain carbon and hydrogens as the only two elements are called as hydrocarbons. Okay, example ethane is one of the one example of hydrocarbon only. So molecular formula of ethane is what? C2H4. Actually it falls under alkane. Try to understand alkane first. Alkane is a saturated hydrocarbon. It is a saturated hydrocarbon. Okay, try to understand first alkane. When we talk about alkane, it has a general formula CnH2n plus 2. This is the general formula for alkane. Here to name this we are using the suffix ane. Suffix ane is used. Okay, we are using some root word depending upon the n. For example, whenever n value is 1, the root word we are using is meth. Meth. Okay, whenever n is 2, we are using eth. 3, prop, like that. For example, you see here, put the value of n is equal to 1 in this. So when you take n is equal to 1, we can write C1H, 2 into 1 plus 2, 2 into 1 plus 2, that is C1H4. So as I told you, the root for one carbon we are using meth and suffix we are using ane. So what is this? Methane. Okay, na? Methane. Similarly, if you take n is equal to 2, so C2H2 into 2 plus 2, that is C2H, 2 to 4 plus 2, that is 6. Okay, so for 2 carbon we are using the root words ether. So this is called as ethane. It is called as ethane. Similarly, we can see up to 10 you should remember. Okay. Okay, alkanes you can see. Okay, alkanes are the saturated open chain hydrocarbon in which the carbon atoms are bonded to each other by single covalent bonds, and each carbon atom is bonded to carbon on hydrogen atom to give maximum covalency of 4 only. Okay, how? I will explain you. Okay, general formula of alkane is what? CnH2n plus 2. So alkanes generally burn in air with a blue and non-sooty flame. Okay, see here, as I told you, first carbon is what? CH4. Okay, first hydrocarbon is what? CH4. So see, carbon is having 4 valence electron, yes or no? Okay, and what about hydrogen? Hydrogen is having 1 valence electron. Hydrogen to become stable, it will take 1 electron and it can become stable by duplet rule, yes or no? Now what about the carbon? Carbon is having 4 valence electrons, so it needs another 4 electron to become stable. So it will take 1 from here, 1 from here, 1 from here and 1 from here. So you can see here between carbon and hydrogen 1 single bond is formed. 1 pair is here, that's why again single bond here. Again 1 pair is here, single bond. Yes or no? So like that we have alkanes. Okay, now here you can see some for n is equal to 2 we will get ethane. There are some properties of methane and ethane. Physical state, methane is colorless and odorless, ethane colorless and odorless, and it is non-poisonous. Boiling point of methane is minus 162 degrees Celsius, whereas ethane is minus 89 degrees Celsius. Melting point minus 183 degrees Celsius. Okay, melting point minus 172 degrees Celsius. Solubility, negligible soluble in water but soluble in organic solvent. Here also sparingly soluble in water, completely soluble in organic solvent like alcohol. Okay, where we are using the methane, try to understand. Methane is a source of carbon monoxide and hydrogen. Okay, it is used in the preparation of useful compounds like ethine and methanol. It is employed as a domestic fuel also. Ethane is used in the preparation of ethene, ethanol and ethanoic acid also we can form. Yes or no? So here we can see, okay, let's talk about a functional group. Okay, what is functional group? Okay, so functional group, when we talk about the functional group, it is an atom or a group of atoms which determines the properties of the compound or especially organic compounds. Okay, so some group or atoms which attach with the carbon compounds and they give some chemical properties to the compound is called as functional group. For example, halogens, okay, generally represented as X. Group 17 elements, especially chlorine, bromine, iodine, fluorine. So these are halogens. Okay, yes or no? So here we are using the suffix. Okay, for example, you see methane, you see now, methane is CH4 right now. In this, if one hydrogen is lost, what it becomes? CH3 with one free valency. Why? Because carbon here, four atom of hydrogen is there, means it is fulfilled. One hydrogen is lost, so it become what? CH3. So there is a free valency, yes or no? In this free valency, suppose, okay, Cl comes and attached, so it is become chloromethane. In this free valency only, if you see, OH comes and attached. OH is a functional group called as alcohol. Okay, so it is known as methanol. Okay, because suffix we are using is all. We will discuss in detail. Okay, aldehyde is CHO. It is again a functional group. Okay, here we are using the suffix al. Ketone, CO. Okay, CO is the ketone. Here we are using the suffix ONE. Carboxylic acid, COOH. Okay, we can write like this: C double bond O, single bond O, single bond H. So it is a suffix we are using is oic acid. Ester, COO, like this: C double bond O, single bond O. This is ester. So we are using the suffix O8. Alkene, double bond is there, carbon carbon double bond. We are using the suffix ENE. Alkane, single bond is there, suffix is ANE. Alkyne, carbon carbon triple bond is there. Okay, we are using the suffix YNE. Yes or no? So you should remember. Here are some nomenclature we should discuss. Okay, let's see. Nomenclature are also called as IUPAC nomenclature. Okay, International Union of Pure and Applied Chemistry. It is an organization, okay, which decides the rules for the nomenclature. So in this system of assignment of names of two organic compounds are there. Okay, just we just discuss system of nomenclatures are trivial system and IUPAC, that is International Union of Pure and Applied Chemistry systems are there, trivial systems and IUPAC nomenclatures. Okay, halogens, when we talk about halogens, for halogens we are using the prefix meth. Okay, meth, these are actually root words. These are nothing but root words we can say, depending on the number of carbon atoms. Okay, if number of carbon atom is 1, we are using meth. If number of carbon atom is 2, we are using eth. If number of carbon atom is 3, we are using prop. If it is 4, we are using but. 5, we are using pent. 6 is there, means we are using hex. Okay, for 7 we are using hept. For 8 we are using oct. For 9 we are using non. Yes or no? For example, let's see. Okay, alkane. I am just taking alkane only. Alkane, what is the formula I told? Okay, CN H2N plus 2. Put N is equal to 1. Okay, substitute here. So we will get a C1 H2 into 1 plus 2, that is, so this is called as methane. Okay, na? Take N is equal to 2. So for N is equal to 2, we are using the root word eth. So we can write a C2 H2 into 2 plus 2, that is C2H6. This is called as ethane. Okay, similarly N is equal to 3, we can write a C3 H2 into 3 plus 2, that is 8, that is propane. Similarly N is equal to 4, we will get a C4H10. So whenever hydrogen atom is 2 more than the 2 times of carbon atom, it is alkane. Try to understand. So for 4, number of carbon atom is 4, we are using but. So it is a butane. It is what? A butane. Similarly N is equal to 5. What will write? C5H. 5 2 ja 10 plus 2, 12. That is pentane. Yes or no? So like this. Okay. And similarly alkene is there, alkyne is there, methane generally does not exist, methane also does not exist. First member of alkene and alkyne does not exist. Okay. Okay. Okay, when we talk about alkenes, let's talk about alkenes. So alkenes are the unsaturated open chain hydrocarbon in which at least one carbon atom is bonded to each other by double bonds. Okay, so alkenes, you see here, alkenes formula is what? CnH2n. This is the general formula for alkene. Suffix we are using for alkene is ene. We are using ene. The first member of alkene starts from n is equal to 2. So let's start n is equal to 2. So we will get C2. Okay, H 2 into 2, that is C2H4. Yes or no? So how we are going to draw structure of C2H4? Carbon carbon, there is a double bond first, and as carbon is a tetravalent, so you have to fulfill the tetravalency. Okay, it means it can make 4 bonds. With this you see 1 2 3 4, with this 1 2 3 4. So 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen. So as the 2 carbon is there, so we are using that root word eth, and suffix we are using ene. So it is what? Ethene. Let's take one more, n is equal to 3. So we can get C3H 2 into 3, that is 6. How we are going to draw the structure? Let's see. There are 3 carbon atoms, yes or no? Between any 2 carbon atom there will be a double bond. Okay, so you can put here double bond, or your wish only, and you have to fulfill the tetravalency, means you have to make 4 bond. With this you can see 1 2 3 4, with this 1 2 3 4, with this carbon 1 2 3 4, and you can fill the hydrogen atom 1 2 3 4 5 6. So 3 carbon is there, means prop, and suffix is ene. So this is what? Propene. Yes or no? So general formula you can see CnH2n. Alkenes burns in air with a yellow or sooty flame. Okay, and alkenes undergo generally addition reactions, we will discuss. Okay, here we are using the alkenes. So ethene is used in the making polythene actually. Okay, so n molecules of ethene forms polythene. It is also used in ripening of fruits. It is used in making epoxy ethane. It is used in the reproducing oxyethylene flame, which is used for cutting and welding of metals. Yes or no? It is used in the manufacture of synthetic chemicals also. Okay, so these are the uses of. Now let's talk about another concepts. Bonding in carbon compounds we have discussed. Okay, covalent compounds actually. Okay, so I have made a separate video for bonding, chemical bonding, so you can watch that video also and learn how the bonding takes place. Now we are going to discuss isomers, okay, and homologous series also. When we talk about isomers, as I told you that these are the compounds having same molecular formula but different structure. Okay, so let's talk about the isomers of alkane first. Isomers of alkane. Okay, so I will open the new page. Okay, isomers. Let's start the isomers. Okay. Okay, isomers. So iso means same, mers means part. Okay, isomers are the compound having same molecular formula but different structure. Okay, so example you can take isomers of butane. Isomers of butane I am explaining first. Butane formula is what? C4H10. Yes or no? So how we are representing, how we can arrange these 4 carbon atoms like this. We can arrange in a 4 in a straight chain. Okay, and you have to fulfill the tetravalency. Single bond is there, means 1 2 3 4, with this 1 2 3 4, with this 1 2 3 4, with this 1 2 3 4. Yes or no? So this is what called as normal butane. This is just normal butane. Okay, na? Next what we can do, we can write 3 carbon in a straight chain and 1 in a branched. Okay, na? So you can see fulfill the tetravalency. 1 bond is there, 1 2 3 4, with this 1 2 3 4, with this 1 2 3 4. Yes or no? With this 1 2 3 4, you can see here 1 2 3 4 5 6 7 8 9 10. This is called as isobutane. What is called as isobutane, or also called as 2-methyl. You can see 1 2 3. second carbon contain methyl group, so this is also called as 2-methyl propane. Longest chain is 3, so this 2-methyl propane. We can write okay, this also as like this. Okay, you can write 3. Okay, normal butane isobutane. So it is there are only butane, isobutane. Yes, one more I will tell you how it is. 4 carbon you can write. Okay, so 1 2 3 4, 2 hydrogen you can write 1 2 3 4, 2 hydrogen 1 2 3 4. No, this is not the isomers actually, this is a alkene actually. Okay, now cycloalkane. So butane has 2 isomers, normal butane and what, isobutane. Now we talk about pentane. Let's talk about pentane. So pentane formula is what, C5H12, yes or no? So we can write 1 2 3 4 5 in a straight chain. Fulfill the tetravalency means you have to fulfill the hydrogen atoms. So a single bond is there means 3 hydrogen, 2 bond is there means 2 hydrogen, 2 hydrogen, 2 hydrogen and 3 hydrogen. So this is what a normal pentane, yes or no? Okay, we can write 4 in a straight chain, 1 in a branch chain. So one bond is there means 1 hydrogen you can put here, single bond is there means 3 hydrogen, 1 2 bond 2 hydrogen. Okay, here we can see 1 2 3 1 hydrogen with this 1, so 3 hydrogen will come, 1 2 3 4. This is called as isopentane. Okay, or also called as second carbon contains methyl group, right now. So 2-methyl butane. This is also called as 2-methyl. How? 1 2 3 4, here methyl group is there, so 2-methyl butane, IUPAC nomenclature. Or we can write like this: 3 you write in a straight chain, 2 you can write in a branch chain. Okay, now fulfill the tetravalency. A single bond is there, so you have to write 3 hydrogen, single bond 3 hydrogen, single bond 3 hydrogen, here single bond 3 hydrogen. Here we can see 1 2 3 4, no hydrogen, yes or no? So 3 3 6 plus 3 9 plus 3 12. So all are having formula C5H12. Here this is called as neopentane. Okay, are also called as 1 2 3. See, second carbon contains 2 methyl groups. CH3 group is what, a methyl group. So we can write 2, 2 dimethyl. 2, 2 dimethyl. The longest chain is 3 carbon. So it is propane. Okay, na? So this is how isomers we can understand. Please make a note of this. Okay, now let's discuss a homologous series. Okay, we talk about a homologous series. What do you mean by homologous series? Okay, when we talk about a homologous series, it is a series of carbon compounds having the same general formula, in which successive member differ by CH2 group. Okay, so once again let's go to this. Okay, try to understand homologous series. When we talk about homologous series, it is a series of organic compounds, okay, which is having same general formula, in which successive member differ by CH2 group. For example, alkane you take, alkane. What is the formula? CnH2n plus 2. Put n is equal to 1, what will get? CH4, yes or no? Put n is equal to 2, what will get? C2H6. Put n is equal to 3, what will get? C3H8, yes or no? So you can see clearly there is a difference of 1 carbon, 3 minus 2, 1 carbon and 8 minus 6, 2 hydrogen. Here also there is a difference of CH2 group. Take n is equal to 4, C4H10. So there is a difference again of CH2 group. So they have the same general formula, in which successive member differ by CH2 group. This is the definition. Properties if they ask you, characteristics if they ask you, so you can say they have the same general formula. Okay, they differ by CH2 group. The physical properties of these homologous series are different, like physical properties, boiling point, melting point, state will be different. Okay, for example, alkane, first 4 member of alkane is what, gas, next up to 17 is liquid, and after 17 it is waxy solid, yes or no? Similarly, melting point, boiling points are different. Okay, when you increase the number of carbon atoms, so boiling point and melting point also increases, yes or no? And CH2 means how much is the difference of the atomic mass unit? See, carbon atomic mass is 12 and hydrogen 2 into 1, that is 2. So there is a difference of 14 atomic mass unit between the successive member. That also you can remember. I hope you have understood some concepts of alkane, functional group and homologous series. Okay, let's talk about alkyne. Okay, when we talk about alkyne, alkyne has general formula CnH2n minus 2. Here we are using the suffix YNE. What is the suffix we are using? YNE. Okay, so first member of alkyne is what? With n is equal to 2. So substitute n is equal to 2. You will get C2H. 2 into 2 minus 2. So we will get a C2H2. How is the structure? Here between carbon carbon there is a triple bond. Okay, and here single bond. Yes or no? So this is a 2 carbon is ether, suffix is YNE, ethyne. Similarly, if you take n is equal to 3, okay, if you take n is equal to 3, you will get a C3H. 2 3 ja 6 minus 2, that is 4. So C3H4, how we are going to draw the structure? 1 2 3. First you write single bond. Between any two carbon there will be a triple bond, yes or no? Correct or not? Now fulfill the tetravalency. With this you can see 1 2 3 4. With this 1 2 3 4. With this 1 2 3 4. Now fulfill the hydrogen 1 2 3 4. As you can see, there are 1 2 3 4. Okay, hydrogen is there and 3 carbon is there. So 3 carbon means what? Prop. Suffix we are using is what? Ine. So this is what? Propyne. Yes or no? Correct or not? Okay, here one more we can see isomers of alkene. Isomers of alkene. Okay, generally, okay, alkene and cycloalkanes are isomers. Try to understand. Okay, cycloalkane also have a general formula what? CnH2n. Okay, and alkene also have a general formula what? CnH2n. Take n is equal to 4, you see, for example. Okay, so we can write C4H8, yes or no? Now if you talk about the alkene, 1 2 3 4. Okay, so you have to put double bond between any two carbon, you can put here. Fulfill the tetravalency 1 2 3 4. With this 1 2 3 4. With this 1 2 3 4. With this 1 2 3 4. Substitute the hydrogen 1 2 3 4 5 6 7 8. This is what? Butane. This is just butane. Or we can write 1 2 3 4, yes or no? And fulfill the hydrogen atoms. How many hydrogen atoms based on the bond? 1 2 bond is there means 2 hydrogen. 2 bond is there means 2 hydrogen. 2 bond means 2 hydrogen, yes or no? Again 2 hydrogen. This is called as cyclobutane. Okay, cyclobutane. So alkene and cycloalkanes are what? Isomers. Okay, one more isomers is possible for C4H8, yes or no? How? Write 3 carbon. One you can write in a branch. Okay, na? So you have to fulfill the tetravalency. Double bond you can put here. Yes or no? So you can see with these two bonds are there means 3 4. This 1 2 3 4. With this 1 2 3 4. With this 1 2 3 4. No possible. Not possible. 1 2 3 4 5 6 7 8. This is called as what? 2-methyl propene. Okay, so C4H8 has 3 isomers. Normal butene, sorry, this is butene. What is this? Butene, because double bond is there, yes or no? So butene, cyclobutane and 2-methyl propene. Okay, so this question have been asked. I hope you understood the isomers, homologous series, functional group. Okay, in the next video we will discuss the chemical properties of organic compounds. If you have understood, please share with your friends and subscribe the channel. Thank you.